elimination. Elimination. Again, this is section 6.3 and 6.4. We're going to complete these together. Elimination is just like it sounds. We are eliminating a variable, either all of the x's or all of the y's. In order to eliminate, we have to have opposite terms. For example, if we have 2x and negative 2x, are those opposite terms?
Yes.
Yes, if I was to add those together, it would be 0. If we have 3y, negative 3y, and a positive 3y, are those opposite terms? Yes, if you add them together, it equals 0. That's what we mean by opposite terms. These are called additive inverses. You may have heard that before. Additive inverses, when you add them together, you get 0. What if we had 3x and negative 4x? Are those opposite terms?
Yes.
They're not. If I add 3x and negative 4x, am I going to get 0?
No.
I'm not.
I don't get it.
If I add 2x and negative 2x, so you get 0.
But they're opposite because it's negative and positive.
Right, but what happens when you add 3x and negative 4x? What do you get?
Negative 1.
Negative 1. Doesn't give you 0. If I add these two together, negative 3y and positive 3y, doesn't that give me 0?
Yeah.
2x and negative 2x?
So you can only do this if they're
Right, if we have opposite terms.
so would you just
Right, so here we have to do something, and we'll talk about that later, what to do. Right now, I'm just getting you to recognize what an opposite term is. That's the only thing. Here's our first example. If you would copy these two equations onto your notes, I would appreciate it. 3x plus y equals 5, and 2x minus y equals 10. We are going to add these two equations together. But in order to add the two equations together, I need to have opposite terms. Do I have opposite terms here?
Yes.
Yes. Which two terms, Caitlin, do you consider opposite?
The y's.
Very good, the y's. If you were to add positive y and negative y, aren't we going to get 0? Okay. So let's go ahead and I want you to add these two equations together. I'm going to put a line underneath and a plus sign on the left, like I've got it. We're going to add. Well, what is 3x plus 2x? 5x. Y minus y? That's going to give 0. We can say that those are going to be eliminated, so they're no longer in our problem. The opposite terms, they give us 0, so they're eliminated. When I add 5 plus 10, what do I get?
15.
15. Can you solve this equation?
Yep.
Yeah. Divide by 5, x is 3. How many of you already like elimination better? I told you, I really think you're going to like this one the best. Now we've got x equals 3. We're going to do just as we did in substitution and put it back in. Put it in for either equation. Put it in for x. I'm going to use the first equation. So 3 times 3 plus y equals 5. 3 times 3 is 9. Subtract 9 on both sides. Y is equal to negative 4. 3 comma negative 4. 3 comma negative 4. Our answers are still going to be written as an ordered pair, just like they were in graphing, just like they were in substitution. Let's look at another example. We have x plus 2y equals 4, and negative x plus y equals negative 1.
So if you're looking at it like that, how the x is from
Opposite terms.
yeah. Could you just take that out and just make it perfectly line?
Yep, because they're going to be eliminated. We can use elimination can't use elimination here. Now, to do elimination, we have to have opposite terms. Do we have opposite terms? Yeah. X and negative x, those are considered opposite terms. So x plus a negative x, well, that's going to cancel out. We're left with 2y plus y, which is 3y. And 4 minus 1 is 3. We can solve this equation. How would you solve it?
Y.
Divide by 3, so y is equal to? We're going to substitute back in. Take your value of y, which is 1, and put it back into one of your equations. I'm going to pick the top equation. X plus 2 times 1 equals 4. 2 times 1 is 2.
You got subtract 2 from that. And
Good, Isaac. X is equal to 2. Remember, your answers are always as ordered pairs. 2, comma, 1. How about this example? Can we use elimination here?
Yes.
We sure can. We have opposite terms. Which variable is going to be eliminated? The y's. So let's add the x terms together. 4x plus 2x is 6x. 3y minus 3y is 0. And 16 plus 8 is 24. We can solve by dividing by 6. So x is 4.
4.
Now we need to find y. Doesn't matter which equation I would put 4 back in for. It doesn't. So we're writing some. We want to put 4 in for x. So 4 times 4 plus 3y equals 16. 4 times 4 is 16. We're solving for y. So let's subtract 16. We have 3y equals 0. How would you solve this equation? Divide by 3. So what is y? Not no solution. What's 0 divided by 3? 0. That's okay to have 0. So we have the ordered pair 4, comma, 0.
Is this all we're doing?
Just elimination.
Elimination?
How about on this one? We have a few that are a little different.
Oh, not elimination anymore?
Do we have opposite terms?
Yeah.
No.
We can't do elimination right now. Because if I add x plus x, that's going to give me 2x, isn't it? And if I add 6y plus 3y, that gives me 9y.
There's a no solution?
No, there's a way to solve it.
You're gonna have to do it
Can
like
you
we
put
used to.
a plus and a minus on it to make it?
No, we're gonna
Kind of, Mickey, I think you have the right idea. We're going to have to do something.
You're gonna have to subtract x.
Add a negative, how?
On one of the x's?
Okay, so I can't just say, poof, there's a negative, right? We don't know that much. What?
Minus
Take a
x.
negative off of 10 and put it to the end, but I don't know how you do that.
This is good.
Do you just want to share? Share the negative. Karen, what do you think?
You could solve a little bit and do minus and then rewrite it. Minus x and then it'll be an equal 0.
But that would put x on the right side and y on the left side.
Can you subtract 5 and add 10? Oh, no, you can't.
No, you can do that. Can't you? When there's one on both sides, you just have to get it to the other side again.
Yeah. Well, we could do it that way. There's an
Can you
easier
put
way.
Can you flip it?
Could. Divide it.
What's the easier way?
I feel like it's really easy, but we're just overthinking it.
You are overthinking it. We want it to be negative x, right? That's the idea. We want either this x on top to be negative or the one on the bottom. If I make that negative right there, what else do I have to do?
You have to change something else, don't you?
Yeah, what?
You gotta change the 10 to a positive.
Okay, and what else?
Uh,
Okay. That's what I want it to be.
change.
What did I have to do to this equation to get it to that point that we were able to do that? Yes, what are we going to distribute? A negative. Good job. Was that Molly? Good job. Okay. Good job. We need to distribute a negative. It's like multiplying everything by a negative 1. So if you would, please put that second equation in parentheses and multiply by a negative 1. So somebody had to go down, I don't remember who it was, but they said originally subtract x and then they said subtract 3y. And that way it'll give us an opposite term. That would work as well.
So it would be negative x minus 3y equals 10.
You got it. So we have negative x minus 3y equals 10. Now before we go any further, could we have multiplied the top equation by a negative 1?
Yes.
Absolutely, because that would have also given me a negative 1x, wouldn't it? And that's what I need. So it doesn't matter. We pick the second one or I pick the
So now
second.
you would just mark out, eliminate the x, and it would be 9y.
I'm going to cross off this middle equation so we don't get confused, because we have a new equation right here. So when I add these two equations now, are the x is going to eliminate?
Yeah.
Yes. We have 6y minus 3y, which is
3y.
3y, and 5 plus 10 is?
y
15.
equals 5.
Divide both sides by 3. Y equals 5. Now we need to find x. So we need to substitute back in. I'm going to use the top equation. We know what y is. Y is 5. So let's substitute back in, just like we did using substitution. Six times 5 is 30. Subtract 30. X equals negative 25. So we have negative 25, comma, 5. So just to recap here, this problem was a little bit different because we didn't have opposite terms. We had to make them opposite terms. I'll try one more. This will be our last example. Negative x plus y equals 1. And 2x plus y equals negative 2. Do I have opposite terms? What about those x's? Are they considered opposite terms? If I add them, am I going to get 0?
No.
No, I'm going to get positive 1x if I add negative x plus 2x. Not opposite terms. Do I have a
Can you
thought?
make the positive x and negative y and negative 1?
Okay. To do that, Mika, what do we need to do the first equation?
Simplify by negative
Very good. So multiply that first equation by negative 1. Could we multiply the second one by negative 1?
1. Yeah.
Awesome, yeah. That would be fine too. We picked the first one, so we have negative x times negative 1, the positive x. Negative 1 times y is negative y. And negative 1 times 1 is negative 1. Now when we add the two equations, we have 2x plus x, which is 3x. What's going to happen to the y's? They're going to be eliminated. And negative 2 plus negative 1
Negative 3.
is negative 3. We're solving for x, so divide by 3.
X equals negative 1.
Now we need to find y. So we're going to put negative 1 back into one of the equations. Doesn't matter. I'm going to use this second equation. So 2 times negative 1 plus y equals negative 2. 3 times negative 1 is negative 2.
I
And,
just have a
yeah.
question. You're adding the negatives, so wouldn't you?
Right here is a negative 2 and negative 1.
Yeah, because like on the, there's one like that.
Or you think it should be positive? So you write something here that I have.
No, like I did that one time. It was.
You got a minus there? And then maybe add 2. Minus 1. Right, but that's not, it's really, think of it as negative 2 plus a negative 1. Because we're really adding. If we have negative 2, if we do negative 2, plus the negative 1, that's the same thing as saying negative 2 minus 1. That was still negative 2. Let's just let them calculate with it. Okay, the last thing I need to do is write my ordered pair. So we have negative 1, 0. How many of you think the other 2 methods are challenging? So that. Okay. You like this one better?
Yeah.
I told you what I thought you would.
We're gonna like it better tonight, and then tomorrow when we come back, you're gonna add stuff we're not gonna like it.
Not too much. Yeah. What? Not right now. Not right now. Okay. We are going to do some practice problems with this. This is not the correct assignment, so let me adjust this. It is incorrect. Your assignment is going to be on page 352, 7 through 18. Please utilize your time, guys.